Okay, my Prealgebra students, it's starting to get fun now. We're in lesson 71. We're talking about powers of fractions and roots of fractions. So we remember that an expression that has an exponent is called an exponential expression. So for instance, this is an exponential expression. It literally means 2 is multiplied 3 times. 2 times 2 times 2, which would be 8, right? Sometimes we use the word power to describe the value of the exponential expression. We say that this is 2 to the third power, right? Fractions, as well as whole numbers, can be used as the base of an exponential expression. We simply perform the multiplication as we would with whole numbers on the top and the bottom. So, for instance, if we had 1/2 to the power of 3, that would be 1/2 times 1/2 times 1/2, which would be 1/8. So you see it works the same way regardless of whether it's a whole number or a fraction. So let's look at a practice problem. In 71.1, we have two problems. 2/3 to the second or squared power, and we have 3/4 to the third or to the power of 3, to the third power. So this one is quite simply going to be 2/3 times 2/3, which equals 4/9, right? And this one would simply be 3/4 times 3/4 times 3/4, which would end up being 3 times 3 times 3 is 27. And 4 times 4 times 4 is 64. All right? Easy peasy. You just treat it the same way you do a whole number and multiply it out. Let's look at roots of fractions. I'm going to clear the page. When we use the radical sign like this, right, and we have a little number here and a number of, let's say, 8, any number under here, we say what number used as a factor 3 times equals the given number. That's what we're asking. And in this case, we know that 2 times 2 times 2 is 8. So this factor is used 3 times to give us 8. So the answer to this is 2. We can do the same thing with fractions. So if I said the index 3, the cube root of 1/64, what factor could we use that would give us this if we used it 3 times? And the answer to that would be 1/4, because 1/4 times 1/4 times 1/4 is equal to 1/64, because 4 times 4 times 4 is 64. So 3 identical factors. We're looking for 3 identical factors, and that's what it is. So the same thing that we can do with roots on whole numbers can be done with roots of fractions as well. So let's look at a practice problem for this. And this is going to be 71.2. And we have the cube root, or the square root, sorry, of 9/16. Now, when there is not a number here, then by default, the number is 2. So we're looking for 2 identical factors. So one of the things that you can do to simplify a fraction, or a root like this, a fraction root, I'm not sure exactly how you say it, you can break it down into parts. So this can equal the square root of 9 over the square root of 16. That makes it a little bit easier to see what you're doing, and you're still treating it like a fraction. So the square root of 9 is 3, because 3 times 3 is 9. And the square root of 16 is 4, because 4 times 4 is 16. So if you have a hard time envisioning how to break down a fraction, simply break it into its own root and put it in fraction form. So let's do 71.3 the same way. So this time we're looking for the cube root of 8 over 27. So we're going to do the same thing. We're going to look for the cube root of 8 over the cube root of 27. So we know that 2 times 2 times 2 is 8. So that's going to be 2. And we know that 3 times 3 times 3 is 27. So this is going to be 3. Okay? It's that simple. All you have to do is split it apart and put this symbol over each one of the parts of the fraction. Just break it into pieces and solve each one independently, and you'll get your answer. And it is just as correct as if you were to try to do it all at once. Now, at some point, as you get better at this, you can skip this step and do it in your head. And that's great. But until you get to that point, do it like this. Break it apart, break apart the numerator and the denominator, and you will still get the same answer. And that is all we have for lesson 71. So I will see you in lesson 72.